In the name of God. Hello, dear students. My name is Masood. I'm a physics teacher. We are in Ferkhwa's website at your service to explain physics curriculum, grade 10. So far, we talked about properties, mechanical properties of matter, especially solid. This chapter, you know that this chapter focuses on solid especially. In previous lectures, we talked about some properties like density, like rigidity, elasticity, and tension. I think tension. I explained these properties. I explained 4 properties. Right now, I'm gonna let's say move on to the 5th property of solid. Which is stress. Right? What's the stress? Let me explain stress for you. Let me read the title for you. Read the definition for stress. It's the force applied on a unit area of a cross section of a wire. Force applied on a let's say unit area, right? So we have 2 things here. What are these? What are the things that we focus on it? Force, and I underlined it for you for let's say better understanding. I underlined it for you. Uh, I want you to focus on 2 things. I want you to focus on force and area. So applying force on a unit area is called stress, right? Applying force on a unit area. Symbolically, stress is denoted by this symbol. This symbol is not English actually letter, it's a Greek letter, sigma. It's called sigma, yeah? I want you to read it as sigma. So sigma means stress. Sigma is equal to T over A, tension over area. It means force over area, where T is the tension measured in Newton. So T is tension measured in Newton. A, cross-sectional area measured in meters square. And sigma is a stress measured in Newton per meter square or Pascal, right? That's it. This is about the stress. So the unit of a stress is as the unit of pressure. We have a note here. The unit of stress is the same as pressure, which is Newton over meter square or Pascal. So pressure is under quantity. I'm gonna explain it in next chapter, God willing. I'll explain it for you. Actually, stress is a let's say professional word. It's a special word. Excuse me. Stress is a special word, and this word is dedicated only for solids, right? Stress. You cannot use solid. You cannot not use stress for other states like liquid and gas. For other liquids, for other states like liquid and gas, you can use pressure instead of stress, right? But stress is dedicated for only for solids, not for. And by the way, pressure is a general word. You can use pressure, let's say for both, let's say for 3, let's say states of matter. You can use pressure for solid, for liquid, for gases, no problem. But stress is, let's say, a special word actually, dedicated just for solids. That's why we use stress here in our textbook, right? Let's move on to another, let's say, to the diagram. We have a diagram, we have a graph here, right? This diagram talks about what? This diagram focuses on the types of stress. Actually, how many types of stress are there? Based on the direction of tension, stress is divided into 3 categories, which are tensile stress, the first one, number 2, compressive stress, and the third one, shear stress, right? Sometimes we can use breaking stress instead of shear stress, right? Shears. So tensile stress is achieved when tension is perpendicular to area. So when tension is perpendicular to area, we have, let's say, tensile stress. What's the effect of tensile stress on solid or on matter? So tensile stress tends to what? Tends to elongate the wire. So tension in this situation, tension in tensile stress, tends to elongate the wire or a spring. Let me do the simple experiment for you. For example, we have this spring, I have a spring, right? So what's the, I'm gonna make tensile stress for you, right? The tension, so I use, let's say, two tensions at both extremities of the spring. In this situation, you see, so the spring is under tension right now, and the type of stress here, so it's under tension, and I can say stresses appears right now. As stresses appeared right now, I can say it's a tensile stress. Why do you say tensile stress? Because let's say tension tends to what? Tends to elongate the spring. That's why we say this is a tensile stress, right? So whenever you use a tension and tension elongates the wire or elongates the spring, in this situation we have tensile stress, yeah, tensile, right? By the way, the direction of force in tensile stress is perpendicular to the cross-sectional area. This is cross-sectional area, which is a circle, yeah? So whenever you pull the spring from both ends outward, right, in this situation, let's say your forces or your tensions at both ends of the spring are perpendicular to the cross-sectional area, right? This is called tensile stress, right? Let's move on to another type of stress, which is compressive stress. So compressive stress is achieved when tension is perpendicular to the area, right? It's the same as the, let's say, as the previous let's say stress, but of course the first condition is common, no problem. The first condition, whenever you say tension is perpendicular to area, this condition is common for both tensile and let's say compressive stress. But what's the difference here? How can I differentiate, teacher, between the tensile stress and compressive stress? I mentioned it here in the inside the box, inside the let's say rectangle. I said tension tends to what? Tends to shorten the wire. In this situation, in compressive stress, tension tries to what? It tries to, let's say, shorten the spring, shorten the wire. You see? So here, tension try to shorten it. Let me do it for you right now. So we have a spring. This is the initial length of a spring, right? Whenever you push, let's say, the spring inward, right? Whenever you, let's say, apply force inward, or inward direction in this situation, so what happens to the length of a spring? Does it increase? Does it decrease? Right? I'm sure you know the answer. So the spring shortens in this situation. The length of a spring decreases. That's why it's called compressive stress. So what's the difference between tensile and compressive stress? Let me do it for you by a simple experiment, right? This is tensile stress. Why? Because tension tries to elongate the spring. Because tension, let's say, tension acts on the spring outward, yeah, to the outward on the cross-sectional area, outward. But what do you say about this one? This is called compressive stress because tension tries to shorten the wire or shorten the spring. In this situation, tension, I can say, applies on the wire in the inward direction, yeah, inward direction. We have one more type of stress, which is shear stress, and I told you it's sometimes we name it as breaking stress. Shear stress is achieved when tension is parallel to the area. Tension is tangent to the area. So this is the difference between tensile, compressive, and shear stress. In tensile and compressive stress, actually, in the previous categories of stress, right? Tension was perpendicular to the area. But right now, in shear stress, tension is parallel to the area. So the direction is parallel or tangent to the surface area. And what does tension do here? What does it try to do actually? It tries uh, to cut the wire. It tries to break the wire. That's why we name it as breaking stress or shear stress. Let me do the experiment for you. Whenever you use, for example, whenever you play with, for example, Rubik cube, whenever you play with this cube, so you use shear stress. You use shears. So this is called shear stress. You see, it cuts the material, it cuts the object, it cuts the solid. That's why. And by the way, the forces are tangent. The forces are not perpendicular. Actually, you don't press it and you don't pull it. You just apply force in tangent direction to the surface area or parallel to the surface area. We have one more example. Here we have one more cube here. Look here. I use compressive, I use shear stress right now. Shear stress. This is shear stress. By means of shear stress, I can cut the metal. I can cut the object. We can break the solid, right? This is solid. You can break it. So they are what? Whenever you play with this cube, actually we have what? We have shear stress. We have one more example, and it's very easy. I want you to do it at home. Bring a, for example, box, right? So the shape of box is square. I want you to use two, let's say, parallel tensions at both, let's say, at upper and lower surface area of the box, right? Like this. So what happens to the box here? The box changes to the what? To the lozenge. This is the original shape of the box, which is actually a square, right? Whenever you apply force on it, whenever you use two tensions in parallel direction, so the let's say the object changes to what? To the lozenge. That's why this is called shear stress, right? So this is about, let's say, types of stress. We explained the types of stress. Right now, we have a note here. We have two tips here. Tip number one, it says direction of applied force determines the type of stress. So direction of applied force, direction of tension determines the type of stress. You know that whenever you, let me do another, let's say, another experiment for you. I want you to tell me about the type of stress, right? Right now, whenever you weigh something by this scale, spring scale, right? What happens to the length of a spring, right? Whenever for example, I pull this hook, I pull it, and a spring, let's say, comes down. A spring, let's say, opens, right? The loops of the spring separated from one another. The spring elongates. So name the types of stress. Name the type of stress for me. So this is it tensile stress, compressive stress, or shear stress? Of course, this is tensile stress because, let's say, I try to, or weight tries to what? Whenever you suspend the weight into the end of the spring scale, the weight tends to what? Tends to elongate the spring. That's why using the spring scale means you apply tensile stress on spring scale. So direction matters, right? If the direction is perpendicular, whether we have, let's say, if the tension is perpendicular to the area, either we have, let's say, tensile stress or we have compressive stress. But whenever you use parallel force, parallel and tangent force, parallel tension, actually, in this situation, we have shear stress. So I say whenever we use parallel tension, we have shear stress. So Direction determines the type of stress. And in the previous, let's say, types of stress, we said that whenever you use perpendicular forces, right? Either we have tensile stress or compressive stress. So direction matters. Keep in mind that the direction only determines the type of stress, right? Now, tip number 2. Sometimes shear stress is called breaking stress. I told you during my explanation, I told you about the another name of the shear stress. So we have some questions. Let's discuss it together. I didn't answer these questions. I'm gonna discuss it with you for better, let's say, understanding the subject. Question number 1: the stress resulting from a force applied normally. Normally means perpendicularly, right? So the force is perpendicular. Outward, it says outward to the cross-sectional area of the wire. So name the type of stress. Choose the correct option. Which option is true? It says the stress is actually the tension is perpendicular, or you can say perpendicular or what? Perpendicular or normal, right? So the tension is perpendicular or normal. But maybe you say, teacher, till now I don't understand. We have two options. Either we have, for example, tensile stress or compressive. Which one do we choose? Right? Till now it's not clear exactly, but if you, let's say, take a look at this word, it says outward. So outward tension tries to elongate the wire or elongate the spring. That's why the answer is tensile stress. It's not compressive and shear stress. Number 2, the stress resulting from a force which is tangent. Look here, tangent or parallel to the cross-sectional area is called what? Actually, only we have one, let's say, stress which is due to parallel force. What's this type of stress? Is it tensile stress? Is it compressive or shear? Actually, it's shear stress, right? So let me read question number 3 for you. The stress resulting from a force acts normally. Yeah, it's normally means perpendicularly. I told you, inward. This time it says inward. So focus on the inward. So inward direction, inward tensions. Try to what? Try to shorten the object. Try to decrease the length of the object. That's why it will be compressive stress. Number 4, shear stress always tends to what? Shear stress always tends to blank the metal bars or the spring or metal, right? Does it try to shorten the metal bar? Does shear stress try to break the metal bar? Think about it. Go over it. Does shear stress try to elongate the metal bar, or A and B? Which option is right? I'm sure you know the answer. So shear stress always tries to break the, let's say, solid, right? Let's move on to another question, which is question number 4, right? Yeah, question number 4. Yeah, I answered question number 4 for you. Question number 5. A perpendicular force is applied to the cross-sectional area. So till now, we have two options. Let's say maybe it's tensile or compressive. We are not sure till now. We need more explanation. So till now, we know that the force is perpendicular. It's clear. But it says, and gives rise to elongate. Look here. Whenever it says elongate, so elongate means, so think about it. Which option is true in your opinion? Right? Which option is true? Elongate. Elongation is due to what? Elongation is due to the, which type of stress? Actually, tensile stress. Question number 6. Tangential forces to the cross-sectional area of the metal wire tends to what? Tangential or parallel forces tends to actually lead to what? They lead to tensile stress, they lead to compressive stress, they lead to shear stress, of course, shear stress because they are parallel to the surface area. Number 7, a perpendicular force is applied to the cross-section of a metal wire, right? A perpendicular force, normal force applied to the wire, to the cross-section of the wire. As a result, the wire is shortened. You see, the wire is shortened. The length decreases actually. This stress is called tensile stress, compressive stress, or shear stress, or A plus B. Actually, this answer is right. Compressive stress tends to shorten the wire or spring. The last question about the stress, actually, it determines the type of stress. So what factor determines the type of stress? Which factor? A, direction of applied force. Thus, direction determines the type of stress. B, magnitude of applied force. By the way, whenever we say, when you hear the word applied force, we mean tension, yeah? In other words, instead of applied force, you can say tension. For example, you can say direction of tension or direction of applied force, because tension itself is a force, right? So C, A plus B, means direction and magnitude determines the type of stress. D, temperature of matter. Actually, temperature doesn't matter here because we didn't say any a single word about the temperature. It doesn't have any effect on the stress actually. So it determines the type of stress. Go over it. Among the direction and magnitude, which one is correct? Or both? I'm not sure. Think about it. So sure you know the answer. So direction of applied force or direction of tension determines the type of stress. That's all for today, guys. Thank you for watching this video, and bye for now.